Okay, so we are given the IV characteristic graphs for two components, R and X. R is obviously ohmic, but X is not. We are told that when these two components were connected in series, we have a current of 0.3 amps flowing through them. So let's consult the IV characteristic graphs. To have 0.3 amps flowing through component X requires 1.0 volts of PD across the component. So we now know that the PD across X is 1 volt. Likewise, to push 0.3 amps through resistor R, what is required is a potential difference of 1.5 volts across the resistor R. So now we know what is the EMF of the battery. It's 1 plus 1.5, which is a 2.5 volts. Now, we are going to connect the two components this time in parallel, but the battery is still having an EMF of 2.5 volts, which means now that we have 2.5 volts of potential difference across component X. Let's go back to the IV graph. When a PD is 2.5 volts across component X, a current of 0.5 amps flows through it. So there's a 0.5 amp current through X. Likewise, when we have 2.5 volts across R, 2.5 volts across R, we have a current of 0.5 amps flowing across it. It so happens that the current is 0.5 volts for both of them, but it doesn't have to be so. It so happens for this question. So if we have 0.5 amps here and 0.5 amps through this branch, that means the current through here should be 1.0 amps.